Right, apologies for that mix up there, guys. We have all the solutions here to question 6, and I'm going to skip on to the next page there to question 7, where you can take out your copybooks and correct what you've done. I'm just going to quickly go through and we'll say a sample of these questions here. So, for example, here, if I'm looking here at, let's see, question 6, part E, we're told we have 100 to the power of 3 over 2. We want to simplify this. So what I need to do there is I need to look at the fraction and see how I can manipulate it. Remember when I did the previous, we'll say, lesson on this, we said that whilst we can deal with fractions which are like, we'll say, a half, a third, a quarter, a fifth, if I have an indice which is a fraction and it is 3 over 2, then we can't work with that. So what we have to do is we have to manipulate it. So what we want to do is we want to have a denominator of the same denominator, but we want to have a numerator of 1. So what I do is I take 100 and I'm going to change that to the power of a half, and then I'm going to put brackets around that and say that is to the power of 3. And the reason it's to the power of 3, remember, is because when you have a we'll say an indice, a bracket, and an indice, you multiply those indices together, and what we can see here is that when we look at it, that 3 will multiply by 1, which will give us 3, and then we can assume that's 3 over 1. 1 by 2 would give us 2, so therefore 100 to the power of a half to the power of 3 has the same meaning as 100 to the power of 3 over 2. So then we look at our fraction, and we recognize that 100 to the power of a half is the same as the square root of 100, and that is to the power of 3. So again, recall that anything to the power of a half is always going to be the square root. If I had, for example, 1 over 3, it would be the third square root. If I had 1 over 4, it would be the fourth square root, etc. So square root of 100 is 10, 10 cubed, 1000. Right, skipping down to question 7. Now, I'm going to scroll down this far so I can correct there A, B, D, E, and I'll scroll down a little bit more then. So let's just go through another example here. Let's again maybe go with question 7E. I have 81 to the power of minus 3 quarters. First thing I need to deal with here is the negative sign. So the negative sign needs to be gotten rid of. When we have a negative indice, I can always assume that the meaning of that is 1 over the whole number and the indice. So this is a law of indices where if I have a negative indice, any negative indice, then I have to bring it all below the line to make it positive. So now I have got 1 over 81 to the power of 3 quarters instead of having, we'll say, 81 to the power of minus 3 quarters. So now that we've dealt with the negative sign, the next thing we should do is we should try to replace this 81 and to the power of 3 quarters. So again, recognize here that 81 to the power of 3 quarters is unsolvable in its own right, so we have to change this. We want a numerator of 1 again, but what we have is 3. So let's change it to 81 to the power of a quarter, and again, I'm putting a cubed outside the bracket. The reason I'm putting that outside the bracket is because 3 multiplied by 1 is 3, and that'll give us 3 over 4 again. So this has 81 to the power of a quarter to the power of 3 has the same meaning as 81 to the power of 3 quarters. Again, the rule of indices where if I have an indice, a bracket, and an indice, I multiply those indices together. 81 to the power of a quarter is the same as the fourth square root of 81 cubed. And now we need to think of what number multiplied by itself, multiplied by itself, multiplied by itself gives us 81, and the answer is 3. So 3 cubed is the answer there. When we, in other words, the fourth square root of 81, as I said, is 3. And then we want to cube the 3, we'll get 27. Right, so again, I'm just going to scroll down here, and you can pause the video here to have a read of the writing, but that was the homework there from yesterday. Right, so we're moving on to something new today. We are looking here at page 96, question 8. So you might have this in front of you. in your on your lap, whatever, guys, because we're just going to correct through. How would you do a question like this? So let's say, for argument's sake, we are told to prove 216 to the power of 1/3 is equal to, and we're told 8 to the power of 1/3, 27 to the power of 1/3. Now, what it doesn't have there in front of us actually is a bracket. But if I ever have a situation where I have, like, it could be something like this, like square root of 2, square root of 3, if they're right next to each other, then that automatically implies that we are dealing with multiplication. Okay, so it's the same for indices, okay, as square roots. If I have 8 to the power of 1/3 next to 27 to the power of 1/3, then it means I should be multiplying them. So what I could do here, just to make it, I suppose, appear like a normal question, we could what we could do there is we could put a bracket around the 8 to the power of 1/3. We could put a bracket around 27 to the power of 1/3, just to recognize here that that is a multiplication there. Right. What we need to do here is we need to simplify it. Okay. So simplifying this involves starting, we'll say, for example, with the left. So 216 to the power of 1/3 could be rewritten as the third square root of 216. Okay, that is the simplified version there of, we'll say, 216 to the power of 1/3. Now, we know that the third square root means what number multiplied by itself again will give us 216. When you work it out, you should get a value of 6. Okay, so 6 by 6 is 36, and 36 by 6 again is 216. Right, so that is, so we've solved the part on the left. We want to solve the part on the right, and then we want to see if they're equal. So let's have a look at this. We are told here we have 8 to the power of 1/3. 8 to the power of 1/3, remember, is the same as the third square root of 8. The third square root of 8 is equal to what number multiplied by itself gives us 8? The answer is 2. Right, don't forget we're going to have to multiply these after, but what we have here is the third square root of 27, okay, and that is what number multiplied by itself again will give us 27. The answer is 3. Now, in its current form, what I have there looks a bit messy, so I'm just going to do a little bit of cleaning up on this. I'm going to rub out this equal to sign, and I'm going to write in, I can actually just move that equal to sign there a little bit. So 6 is going to be equal to, and we know that these are supposed to be multiplied. 2 by 3 is 6 equals 6. It is. So the answer is true. That would be how I approach that question 8 there in front of us. Okay, so very quickly, what steps did we take? What we did was we looked here and we said 216 to the power of 1/3 can be rewritten as the third square root of 216. Remember, any number with a fraction as an indice needs to be rewritten. If the numerator is 1, then straight away I can say this is the third. I can use the denominator, and that denominator will go outside the square root, and this becomes the third square root of 216. Again, what I see here, I suppose one important step here is to recognize that anything like this where we have 8 to the power of 1/3 and next to it we have 27 to the power of 1/3 automatically implies multiplication. Okay, that's how we do question 8 anyway. So what we'll do now next is we'll have a look here at question 9. Basically the same thing, only you are using everything that you know now about indices to solve it. If I have 81 over 25 in brackets, and all of that is to the power of a half, what this really means is square root of 81 over the square root of 25. Why? Because what I do to one, I have to do to the other. If there's a bracket surrounding the whole fraction, and we're told that this is to the power of a half, then the power of a half would change the value into a square root, so the square root of 81, and But you also have to do that to the denominator here, which is 25, so square root of 25. Therefore, when you work this out, you should get a value. What's the square root of 81? The value is 9. What's the square root of 25? The answer is 5. Right, so that would be how you answer that question there. Now, sorry, there was a little bit of a lag on that. I don't think there's anything too much to that. There's a number of different questions there in question 9 there that are quite similar. So you just have to follow the rules there that I've introduced to you today. Right, I'm going to get out of this now, and I'm going to go on to a third type of question that you're going to have to attempt for me. So let me see if I can find it. Right, now I should have my book open in front of me. Right, how do we approach question 13? Right, question 13, we're told write each of the following in the form 2 to the power p. Right, so the issue here, I suppose, like some of these are actually very easy. So I'm going to I'll just show you how easy one of them is to begin with, and I'll show you, for example, part A. So we are told write each of the following in the form 2 to the power of p, and I'm told I'm starting here with 4. Well, 2 what, in other words, is the same as 4, 2 squared. So the answer there, 2 squared, is the same as 4. So in other words, that is now written in the form 2 to the power of p. But I want to show you maybe one that's a little bit more challenging. So let's have a look here at, for example, let's have a look here at part E. How do I rewrite if I was told I have a half? How do I rewrite that as 2 to the power of something? Well, what you have to do there, first of all, we know we're definitely going to have 2. You have to recognize one of the rules that you've encountered so far. I know that anything to the power of a minus sign will bring the value, can be changed into a fraction. So if I recognize here that 2 could also be written as 2 to the power of 1, then I should be able to recognize that if I want to write this in the form 2 to the power of anything, then the value here would be 2 to the power of minus 1. Why? Because remember, when we encountered anything like this, 2 to the power of minus 1, then what we said was the law of indices is that that's the same as 1 over, and you can change this indice to become a positive, so 1 over 2 to the power of 1, which is the same as a half. So that doesn't matter what number I have. Let's say, for argument's sake, if I have 9 to the power of minus 1, then 9 to the power of minus 1 could be rewritten as 1 over 9. So again, if you can't remember that rule, well, you need to revise it, okay? So that is how you do part E, and I'll just do one final part for you, and then I'll let you go. So let's see, part I. Now, for this one, what have we got? 1 over the square root of 2. Now, you're going to have to do a little bit of manipulation on this again. So recognize, what could you change any of this to? So we can't really change 1 for the time being, but we could be able to change, we'll say, the square root of 2. The square root of 2 could be changed to 2 to the power of a half. Okay, and the next thing then is recognize, how do I bring this 2 to the power of a half above the line? Well, again, I follow my indice rule, and what I would notice there is that this becomes 2 to the power of what? 2 to the power of minus a half. Same rule applies. If I want to bring, if I have a numerator of 1, and I have a fraction, or say a positive number down here, what I can do is I can bring this above the line, and I can change we'll say, the sign of the indice. Right, so that is how we approach our homework for tonight. I will post this on Google Classroom, and you already know what your homework is. Okay, we'll talk to you later.